Okay, students. So, in this video, we will show you how to fix the given workpiece in the chuck. Okay, and also we will show you how to do a facing operation. I feel probably you would be knowing what is a facing. Okay, facing is a process that is used to reduce the length. If the face of the given workpiece is not proper, you can see it's not having a flat surface. Okay, in order to make the surface flat, the operations what we do is called as facing. Okay, so to do these facing operations, you have to use the chuck. So this is the chuck. You have to fix the workpiece inside the chuck. Okay, so normally you have to fix like a 3/4 portion of the workpiece should go inside the chuck. Okay, if you fix like in the other way, like 3/4 should go inside the chuck and 1/4 portion should be outside the chuck. If you fix in the other way, what happens is that there will be a wobbling and a proper facing is not possible to do. Okay, so in order to avoid the wobbling of a workpiece, you have to fix in that way. You like a 3/4 inside and 1/4 of the workpiece outside. Okay, and we will be doing that facing operation by using this V point single cutting edge cutting tool. Okay, yeah. So now the tool has been fixed in the chuck. So you can see by using a carriage, we are bringing the cutting tool near the workpiece. Okay, so the tool post has to be fixed properly. So there is no angle like at what angle the tool has to be fixed. Okay, so in order to avoid or in order to reduce the area of contact between the tool and the workpiece, so for that reason the tool will be rotated to some angle. So switch on the machine. So you can see the tool is bringing near the workpiece. The workpiece is rotating. Probably I feel you should know the relative motion between the tool and the workpiece in the case of a lathe, right? In the lathe, workpiece will be rotating and the tool will be having a sliding motion. Okay, you can see the same relative motion. Workpiece is rotating. The tool is having a sliding motion. Because of shearing action, the material removal takes place. In case of all conventional machines, you can see the chip that is coming out from the workpiece. So that completes facing operation. So this is the first exercise which you all do when you come to the lab and when you get these lathe operations. Okay, so that completes a facing operation, right? So you can see the side of the workpiece is proper now. It is completely flat. Okay, so after doing this facing operation, the next operation which we will do is called as drilling. Okay, you know what is a drilling is? It's a process of making a hole of some diameter to certain depth. Okay, so the reason why we do a drilling is that since the length of a workpiece is like 200 mm, you have to support the other end of the workpiece. So right now to do a facing operation, we have fixed 3/4 of the workpiece inside the chuck. Okay, but when you are doing operations like a knurling or a thread cutting operations, that the workpiece, the portion of the workpiece which is inside the chuck has to be brought out. Okay, so if it is brought out, there will be a wobbling. Okay, so in order to avoid that wobbling, we will do a hole here. Okay, so in this portion a central drilling will be done. The only reason is to support the workpiece by using a tailstock. Okay, it's a very simple operations by using a attachment. You can see this is a drilling attachment. Okay, various attachments are available in the lathe. Okay, one such attachment is this one, drilling. Okay, so to do this drilling, what you have to do is that you have to remove this lock, okay, in the tailstock, and you have to bring the tailstock near the end of the workpiece. You can see easily we can move. So once you should not touch the workpiece actually. So you just need to bring quite close to the workpiece. Then you have to give a feed by using this handle. You can see that's a feed. Okay. So when you start giving a feed, you can see the cutting tool will try to go inside the workpiece, and drilling will be made, or a drill will be made on the side of the workpiece. You can see it now. You can see the chip that is coming out from the workpiece, or you can say from the tool. This is done just to support the workpiece. Okay, so that completes the drilling operation. So now drilling is done. You can see here. So drilling was done by using this attachment. Okay, so now we have to remove this drilling attachment. Okay, so you can see now. So drilling attachment is removed. Now a revolving center will be fixed here in the tailstock. Okay, so the reason why this is placed here is that this is just to this is placed to hold the workpiece. You can see the way how the revolving center is. Okay, it will rotate. The reason why it is called as revolving center means that will rotate when you bring or when the tool is in contact with that revolving center. Okay, so you can see now. So once you fix this revolving center, the next step is to loosen this chuck. Okay, and you have to bring out the 3/4 portion of the workpiece that is actually inside the chuck. Okay, so to remove that, chuck key will be used. You can see. Okay, so a little loose you have to make and bring out the workpiece which was inside the chuck. Okay, you can see now revolving center has gone little inside the workpiece. Okay, since the length of a workpiece is like, as I said, it is around 200 mm. If you do not use this revolving center, the tool may wobble or the tool may vibrate. Okay, in order to avoid the vibration and in order to have like a rigidity while rotating, this kind of attachment will be used. Now you can see one end of the workpiece is fixed in the chuck, other end is supported by the revolving center. Okay, the rotary motion will be given by using a motor. Now, so after doing this, the next operation which we'll be doing is turning. Probably I know what is a turning is. It's a process which is used to reduce the diameter. Okay, if you reduce the length, it is called as a phasing. If you reduce the diameter, it is called as a turning. Okay, since you can see the surface of the given workpiece is not proper. Okay, it's not having a uniform diameter throughout the length. Okay, in order to make the surface of the workpiece uniform, okay, right now it is 32 mm diameter. I feel it should be reduced to 30 mm. Okay, so in order to reduce that, the operation which we do is called as turning. Okay, so to do a turning, you have to rotate the tool post. Earlier, I hope you know, while doing a facing operation, the tool was fixed at certain angle. Okay, so to do a turning operation, the cutting tool should be placed properly, like how it is fixed now. Okay, to do a turning operation, the tool will move perpendicular to the surface of workpiece. So to check what's the diameter right now, you can see this is outside caliper. Okay, it's a measuring instrument. Outside caliper will be used. Okay, that will be fixed at the outer diameter of a workpiece, and you can see what's a diameter at present. Okay, so other the measuring tool which we use is a scale. Okay, so once you set that, you can see the present diameter of a workpiece, that is around 32 mm approximately. We have to reduce to 30 mm. Okay, so how to do a turning operations you can see now. If it is not supported in the other end, that's a common sense. It will vibrate or it will wobble. Okay, so to avoid that wobbling, we have done a drilling, and that drilled hole will be used as a supporting place to fix this revolving center. Okay, so to reduce that 2 mm diameter from the workpiece, initially you have to bring the cutting tool slightly near the workpiece. That means it should slightly touch the workpiece. You can see that white portion, what you are seeing in the workpiece, that actually removed portion. Okay, so in order to set the dimensions like exact 2 mm, because tolerance and accuracy plays a very important role, right? So in order to have the exact material removal from the workpiece, that as I said it is 32 mm, that has to be reduced to 30. In order to do that, you just bring the cutting tool near the surface of a workpiece. It should have a slight contact. Okay, then you have to make a slight adjustment here in the cross slide. Okay, you can see right now, once the tool touches the workpiece, you have to set this cross slide to 0. You can see here right now it is 0. Okay, when you rotate 10 mm, you can see a 10 here. When you rotate that 10 mm, that means 1 mm will be removed in the workpiece. Okay, so that means we have to, right now it is 32 mm, we have to remove 2 mm from the workpiece. That means you have to rotate to 20 mm in order to remove the required material from the surface of the workpiece. Okay, so in order to have that accuracy and dimensional stability, okay, so these initial adjustment you have to make before actually going for doing a turning operations. Okay, now it is set. Once it is set, you can remove the material. So to remove the material, you have to use 2 cross slide. One is compound cross slide, you can see that will be rotated with quite low speed. Okay, so when you rotate that, tool will move along x-axis, that is perpendicular to the surface of a workpiece, and the material will be removed. Okay, so now you can see the entire length of a workpiece is actually turned, and right now the diameter is 30 mm. Okay, so the left portion of a workpiece, you can see there is a step. Okay, so the extreme left is actually at 30 mm. Okay, so we just measured by using outside caliper. So once it is measured, once you make sure that the required diameter is 30, and right now the measured diameter is 30, so the same has to be turned on the entire length of a workpiece. See students, now plane turning is done to a diameter of 30 mm. Then after plane turning, you have to do a marking. If you see a manual, the given workpiece is divided and various operations are being done on the same workpiece. Operations such as taper turning, knurling, left hand V-thread, right hand V-thread, square thread, eccentric operations, all these operations has to be done in the same workpiece. Okay, so there is a required amount of length that is required for each of these operations. Okay, so the entire length of a workpiece has to be divided according to the length that is required for the specific operations. Okay, so to mark that, this procedure will be done. You have to just put a chalk piece on the surface of a workpiece, okay, like how it is now. So once you apply the chalk, next step is you have to change the workpiece. Okay, so you can see here, this is actually the diagram showing the various operations that has to be performed on the given workpiece. Okay, so this is available in page number 39 in your manual. Okay, we have done a plain turning operations. Then for the respective operations, say for example for taper turning it is 30 mm, for knurling it is 10. Okay, for thread cutting operation 8 TPA operation it should be 30. Core diameter, the space is required for 10. Okay, then 3 mm V thread it is 25, like that. So you just see these dimensions and the same has to be marked on the workpiece. Okay, so now marking will be done. So to do that marking, you have to use this outside caliper and you have to set the length, required length, like 10 mm or 20 or 30 mm. So once it is set, you have to mark it on the workpiece like this. Yes. So once that is done, you have to indent that. I mean that marking should be there. So to keep that marking for a longer duration, you have to make slight indent on that at that place. That is done by using this V tool. You just see a slight indentation will be done like that. Okay, so similarly the various length that is required will be measured by using outside caliper and the marking will be done on the workpiece. So now marking is done. You can see marking is done right now for core diameter, taper turning. So second one is for taper turning, this is for knurling, and again for core diameter. Okay, so now after this marking, actually you have to do a marking for all these operations. Okay, so we are not done for all the operations. Eventually we will be doing and we will be showing that. So now I will be doing step turning operation. After marking, the next step is doing step turning. Same procedure. Bring the cutting tool. It should just slightly touch the workpiece. Then set the dimensions there and continue the same process or same procedure how you did for plain turning operation. So now core diameter that is required here, it is 26 mm. Okay, to a depth of 26 mm, to a diameter of 26 mm, the workpiece will be reduced. It is not possible to do in a one go. Okay, minimum 1 mm can be removed. Of course, you can remove 2 to 3 mm, but it will damage the cutting edge. Okay, so normally what we would do is we will do it multiple times. That is, since right now the diameter is 30 and the required diameter is 26, minimum 4 run has to be done to reduce 4 mm. Okay, you can try to remove that 4 mm in one go, but it will damage the workpiece as well as cutting tool. There will be lots of vibration. Yeah, students, now diameter is reduced to 26 mm. So once it is reduced, there is a chamfering at the end of the workpiece. So you can see here. Okay, so 3 into 45 degree. That chamfering is done just to avoid the damage. If it is having a very sharp edge, Okay, when you touch it, it may damage your finger. Okay, so to avoid that injuries, this chamfering will be done. It is like the other end of the tool will be used, and the cutting will be done at using a side face of a tool. Okay, you can see now chamfering is done.